Okay, we're going to start our third unit today, and it's on probability. So today we're going to figure out what probability is and how that relates to odds. So in some games, you'll see they'll say you got the odds of winning a game are 2 to 1 or something like that. So odds, probability, chance, they all sort of mean the same thing. A couple of key things to remember is when we're dealing with probability is probability will always go from 0 to 1 in terms of a decimal, or as a fraction it'd be 0 out of whatever 10 and up to 10 out of 10, or if it was a percentage from 0% up to 100%. So it'll always be where it never will happen, which would be 0%, up to where it's guaranteed to happen or it's certain thing, so it'd be 100%. The experimental probability is a little bit different than theoretical. In terms of experimental, is we just get the probability based on the actual results. So if you were to roll a dice 100 times, maybe you would get 20 ones and 15 twos and 12 threes and so on. So based on the experimental actual rolling of it, they might not be equal probability, and you'd sort of have to figure it out that way. So in terms of experimental, you'd actually count up how many actually occurred. So if I said what are the chances or the probability that you rolled a 1 on one dice, and if you did an experiment of 100 times and suppose it came up 15 times, you'd say 15 out of 100. Most of the questions we're going to be basing that on theoretical probability. So that means, assuming everything was fair, everything would be likely to occur. The number we would get would be what we should get is if we were to do this an infinite number of times. So if you were to roll a dice an infinite number of times, you should get all 6 sides showing up the exact same number of times over the long run. And that's what we'll typically use when we're dealing with probability. We won't do what you would actually get, but what would likely happen. So let's do a few questions on probability just so we can be clear on how that works. So let's do a few different scenarios. So the first one is, what's the probability you roll a 5 on one dice? So there's 1 5 on a dice, and there's 6 numbers, so you'd have a 1 out of 6 chance to get it on a dice. So you could leave it as a fraction, and if it is a fraction, you should reduce it, so that's good enough for that one. Let's suppose we're to flip our roll a dice again, except in this case we want to get a 5 or a 6. So if you had a 5 or a 6, that means you'd have 1 out of 6, or would be 1 out of 6 again, so you'd have 2 out of 6 total. Or if you just think about it, how many 5s and 6s are there on a dice? There's 2, 1 5, 1 6, 2 out of 6 chances, which would be 1/3 if you reduce the fraction. Okay, so that's pretty straightforward. Let's do a couple now where if you were to flip a coin. If you flip a coin, what's the chances you'd get tails? There's 1 tails on a coin out of 2, so you'd have a 1/2 chance, or as a decimal it'd be 0.5, or as a percent you'd have 50% chance, right? 50-50 to get heads or tails. What would be the chance if I flip a coin and I got a tails on the first try, and then I want a tails again on the second one? So remember, and means multiply, so you'd have a 1/2 times a 1/2, which would give you a 1/4. Okay? So it's just sort of memorizing what happens when you have ands and ors plus different scenarios. So the next one I got here is cards. So what's the chances you'd get a heart if you randomly drew a card? Well, there's 13 of each suit, so you'd have 13 out of 52, which would reduce to 1 out of 4, which makes sense because out of the 4 suits, you have hearts, clubs, diamonds, spades, and hearts would be one of them, so you'd have 1 out of the 4 suits should show up. Okay, what's the chances you get a heart or a diamond? Well, hearts, there's 13 hearts and 13 diamonds, so you'd have 13 and 13, which would be 26 out of 52, or if you reduce that, that would be a 1/2, or 50%. Okay, what's the chances you'd get a red card and a 7? So if you're to pick one card out, what's the chances it's a red and a 7? Well, there's 7 of diamonds or 7 of hearts, so there's only 2 red cards that are 7 out of the 52. And you could reduce that to 1 out of 26. And the last one, what's the chances you do not get a face card? There's Jack, Queen, King for each of them, so there's 12 face cards. Right? 12 out of 52 would be the face card, so everything that's not a face card would be 40 out of 52. And this will lead us into doing the complement. So remember, Not would mean everything else. So the total would be 1. So if you did 1 minus 12 out of 52, that would give you what aren't a face card, which would be 40 out of 52, and you could reduce that as well. So that leads us just to making sure you're clear on a complement. So if I told you in any sort of event the probability of it occurring is 0.25, then that means the complement would have to be 0.75, right? If you had a 25% chance of something happening, then that means we'd have a 75% chance of it not happening, right? So complement is always just 1 minus the amount, or 100% minus the amount, and either way. So a good key thing to remember is the probability of anything happening and its complement will always add up to the 1 or the 100%. Odds now are a little bit different, so when you get a question that deals with odds, you got to be a little bit careful. It's just like a probability, but instead of being the number that you want out of the total, it's the number you want set as a ratio to the number that you don't want. So you're going to see odds being something like 3 to 1. So that would mean we have 3 things that we want to happen and 1 that we don't. So that means the odds of actually, or the probability of it occurring would be 3 out of 4, right? If we have 3 things that are good and 1 that don't, together they would add up to 4 total. So you'd write it as 3 out of 4. So 3 to 1 odds is the exact same as 3 out of 4 probability. Okay, so let's just do an example. So what's the probability you roll a 4 on a dice? Well, it's 1 out of 6. There's 1 4 out of 6 spots. So the odds in favor, well, there's 1 4 that we want, and then there'd be 5 numbers that we don't want. So you'd write it as 1 2 5. Okay, some cases they'll tell you the odds against, and odds against are just backwards. It'd be 5 to 1. Or in terms of probability, you have 5 things you don't want over the total of 6. So 5 out of 6 would be the odds against. Okay, so you get the idea of how these two things connect. So let's do just a couple quick examples. So if I said you have, let's suppose you have 10 items, and there are 3 red and 7 blue. Okay, so let's suppose you're going to reach into a bag, and you're going to pull out of the 10, you're going to pull out 1 item. So you got either 3 reds or 7 blues. So let's do, what's the probability you get a red? So the probability of a red, you got 3 reds out of 10 total. Okay, what's the odds you get a red? So odds in favor of getting a red would be, we got 3 reds that we want and 7 blues that we don't want. Okay, odds against a red would be just the opposite. We have 7 non-reds and then 3 that are reds. Okay, so you get the idea of how to connect these things. So the probability of a blue would be 7 out of 10. Odds in favor of a blue would be 7 to 3. Odds against a blue, 3 to 7, and so on. So we're just looking at how to connect odds and probability and that type of thing. And that should be it. We'll stop there. We'll do some more of these later on.